Hi folks, let's do a little math. A little math never hurt anyone. So here's number 72. It's sine of all this gobbledygook, but we're pretty good at sine of u, so how about we pick u equals 2 pi little t over capital T minus alpha. Now the only variable here is this little t, and you know that because of the dt. Everything else is just a constant. When I take the derivative, I get 2 pi over big T dt, because the derivative of alpha is 0. So then I go to substitute here. Now this stuff is u right here, so I get sine of u. I need to solve for dt. So dt is equal to t over 2 pi du. So I put t over 2 pi here and du there. Okay, now I need to do the bounds. The little t was going from 0 to capital T over 2. So when little t is 0, u is, okay, when I put in little t 0, when little t is 0, then u is minus alpha. And when little t is capital T over 2, then u is, well, when I put in, let's go over here on the side and do that. I have 2 pi, and then I'm putting in the capital T over 2, and then I have over t. Okay, so what does that reduce to? The 2's cancel, and the t's cancel, and I get pi. So when I plug in little t equals capital T over 2 into this, u will be pi minus alpha. We're going from minus alpha to pi minus alpha. Okay, let's do that. The antiderivative of sine is minus cosine u. We're going to evaluate that from minus alpha to pi minus alpha, and we will multiply that by t over 2 pi. Okay, so t over 2 pi. I'm going to plug in the pi minus alpha, so I have minus cosine pi minus alpha, and then it's minus cosine of minus alpha. Oh my goodness, lots of minuses. All right, let's clean that up then. So t minus 2 pi, t over 2 pi, and then this one is minus cosine of pi minus alpha, and then over here I have, it's plus cosine of minus alpha, but here cosine of minus alpha is equal to cosine of alpha. And you can see that by, let's do a little unit circle over here. If this is alpha, then the cosine is the length along the x-axis, this length right here. And if I do minus alpha, that would take me in this direction. That would be minus alpha, and notice how the cosine is exactly the same. So cosine of minus alpha is the same as cosine of alpha. Okay, so all told, this right here, this portion is plus cosine alpha. Okay. Now, using the periodicity of cosine, so cosine of pi minus alpha, what's that? Cosine of pi minus alpha, well, that's just pi. I mean, it's just this right here. Okay, so let's look at it. So what is pi minus alpha? Pi minus alpha would be this angle here, pi minus alpha. So if we were to go the distance pi minus alpha, it would be over here, and it would have this little angle alpha, and the cosine would be this length. But that's going to be the minus of this length. So the t over 2 pi, this right here is equal to cosine of alpha. And then this is also cosine of alpha still. Okay, and the reason why, I'll say it again. So cosine of pi minus alpha, that's this length right here in this picture. Okay, and isn't that the same as negative cosine of alpha? Because here's cosine of alpha, and it's the same length, but it's the negative, right? But so what I was just talking about was this portion, and then I have an extra minus, so that's why it's a positive cosine alpha. So I have t over 2 pi times 2 cosine alpha, which is t over pi cosine alpha. That's the answer. Now, I mean, this is also the answer right here, but I happen to know about the pi and alpha and everything. So the periodicity, this is the periodicity. So we're able to reduce it more, but it's not a necessary component. I mean, this is correct up here as well. Okay, let's keep going. We have this is the grand finale. It's like the finale of the fireworks show. And the author is showing off his math chops. Say, I came up with this. Look at this one I came up with. All right, so after you've done 72 of these, this is the final one. Okay, so let's see. This is number 73. Not the final exercise, but it's the final one of just the big pile of integrals that was presented to us. Okay, you stare at this a little bit, and if you're looking ahead, you kind of get a little nervous, because if you were to pick u to be the inside here, which is what we want to do, so we have a u to the 4th on the denominator, and then you look ahead and you say, well, I got to have an extra root x somewhere, because when I take the derivative of that, I get 1 over 2 root x. And you're right if you're thinking that. If you weren't thinking that, well, then you still have to just follow your nose. Okay, so we're going to try this 1 plus root x. This is an example where if you look ahead, you kind of get discouraged, and maybe you don't try u substitution, especially once you know more integration techniques. But it actually does work. So sometimes you just have to follow your nose, and you couldn't always see as far ahead as you needed to. All right, so du is equal to 1 over 2 root x dx. And we're going to do a little substitution. On the denominator, I have u to the 4th. And then I still have to substitute for the dx. So look how dx is equal to 2 root x du, and that is not accepted. We can't have x and u living in the same location. So we're going to have to deal with that. And the way we do that is we solve for root x here. Root x is equal to u minus 1. So this is equal to 2u minus 1 du. And that's what I substitute in. So I have 2u minus 1 du. And then I'm going to change the bounds. X is going from 0 to 1. When x is 0, u is 1. When x is 1, u is 2. So my new bounds are 1 to 2. Okay, now before we integrate, let's break this up into 2 fractions. I'll pull that 2 out in front here. And what I'm going to do is I'm going to have u over u to the 4th minus 1 over u to the 4th. You don't necessarily have to write that step, but I am for you guys. Then that's 1 over u cubed minus 1 over u to the 4th du. And then the way we integrate that is we think of it as u to the minus 3 minus u to the minus 4. And then we use our power rule. I'm going to add 1 to the exponent and then divide by that very number. 2 times, oh, I lost my bounds here. We're going from 1 to 2. When I add 1 to this, I get u to the negative 2, and then I divide by that very negative 2. Minus, when I add 1 to the negative 4, I get negative 3, and then I divide by that very negative 3. That's what we have right now. These minuses here are going to cancel. Okay, let's do a little housekeeping. So I have 2, and this is evaluated from 1 to 2. So 2 times, I'm going to get, the second one's positive, so I'll do that. I'll have 1 over 3u cubed minus 1 over 2u squared. See if you believe that. Okay, now we're going to plug them in. So when I plug in the 2, I get 1 over 3 times 8, which is 24, minus 1 over 8. Then I plug in the 1. I have 1/3 minus 1/2. Okay, we get to do some fractions here. Okay, this is 1/24 minus 1 over 8 is 3/24. Then minus 1/3, which is 8/24. And then plus 1/2, which is 12/24. And what do we get? We have, it looks like 13 minus 11, so 2 over 24. And so I get 4 over 24, which is 1 over 6. Okay, wow, look at how long that one was. That's what's going to start happening. These integrals are going to start taking a long time. Now, I took a lot of extra steps because there's fractions and minuses and everything to be careful with there. Okay, there it is, number 73. Put that in your pipe and smoke it. Well, do the whole thing yourself. I mean, start from the beginning and go all the way to the end. Stop looking, and it's okay if you do have to look, but if you look, stop, go back to the beginning, and do the whole thing until you can go all the way, beginning to end, without looking. Number 74. Here we go. We're starting to get into these problems that say verify and show that and prove that and estimate, all the words that just make you nervous. So in this one here, we're going to, our goal is to show this. Show, we got inequalities. Wow, that's all intimidating. We got an integral from -2 to 3. We've got sine of, oh my goodness, it's the cube root of x of all things. And we want to show that that's less than 1. Okay, now if you're a normal person, when you first look at that, you just say, I have no idea what to do. I don't know how to proceed. I don't know whether what I'm showing is proper. So that's okay. You're normal if you're thinking that. So now we want to read the directions a little carefully because often you get little clues in there of what to do. It says verify that f of x equals sine of cube root of x is an odd function and use that fact to show what I've written here is true. All right, well, I remember when we were doing odd functions that if you had, say -2 to 2, right, because when you're on the number line, if you have the same distance, then odd functions do this kind of a thing where you have the same bit on the right as the left, except they have opposite signs, and so the net area is 0. So I'm remembering that. And they're telling me in the problem to show that it's an odd function. So I'm thinking that this portion is 0. And this thing goes to 3, but at least going up to 2, so we're going to 3, but at least this part here is 0. So let's see if it's an odd function. We have, so sine, to put negative x in here and show that the negative basically comes out in front. Okay, so sine of negative x. Okay, so isn't that the same as sine of, let's put a big fat parentheses around it, negative cube root of x? Because that negative, what's the cube root of negative 1? It's negative 1. So I can pull out the cube root of negative 1 and put it in front, pull it outside the radical. Okay, but then we know that sine has that property. Remember, sine of minus alpha was equal to minus sine alpha, right? It's that unit circle property where there's the sine, that's the positive version. If I have minus alpha, then the sine of that is the negative of the original sine. Okay, so that means that this is negative sine of cube root of x, and that's what we wanted to show. If this was f of negative x, then what we ended up with is negative f of x, and that's the condition for being an odd function. Okay, so we can declare that that is 0, and so here's what we know so far. We know that the integral from negative 2 to 3 of sine cube root of x, well, we can break that up. That's negative 2 to 2 of sine cube root of 3 plus the integral from 2 to 3 of sine cube root of 3. Okay, so this is really what we have to worry about, this thing. And here's the principle we're going to use for any function. If I have a to b, and I have some function here, f of x, and we're talking about the area under the curve. So the area under the curve is represented by the integral, right? The integral from a to b of f of x dx represents the area. Well, the area always has to be less than the max times b minus a, because that would be this, if this is the max here, that would be this rectangle. The max of f of x on b of a times this length b minus a, right? This length is b minus a. So that area of that rectangle has to be, bigger than, or it could be equal to the area of under the curve. And similarly, the function has to be greater than the minimum of f of x, or even just 0, right? But if the minimum is above 0, then it has to be bigger than 0. So when we're going from, well, let's just write that in. So the min, right? So the area has to be bigger than the min times b minus a. So the min, let's say the min is right here, right? So that area, the min of f of x times b minus a, that's this rectangle. So you see how the area under the curve is bigger than the minimum times the length of the interval, and it's smaller than the maximum times the length of the interval. So that's what we're going to use to show what they want us to show, this inequality here. We're going to use that it's greater than those things. All right, so what is sine, what's our interval? Our interval is from 2 to 3. Okay, so the integral from 2 to 3 of sine cube root of x. Okay, well, we could take the derivative, right? What's the derivative? It's cosine of cube root of x, and then you got to have times the derivative of cube root of x. But if you take a look at that, you'll see that it's an increasing function. Okay, or you can just graph this and just look at it. But anyway, the derivative, let me write this down. So sine cube root of x prime, the derivative of that is cosine of cube root of x, all times the derivative of cube root of x, which is 1/3 x to the negative 2/3. Okay, but there are no negatives here, and cosine in this range between 2 and 3, it's a little less, it's the cube root also, so the cube root of 2 and the cube root of 3, what are those? Well, this is bigger than 1, but these are also, anyway, you can put them in your calculator and you can see that this is positive. I want to dwell on the calculus part, otherwise we get lost in the weeds here. Okay, but this is positive, and so what that means is that this is increasing. So sine of cube root of x is increasing. Oops. On the interval 2, 3. Okay, so that means that the minimum is where we're at 2. Okay, so the integral from 2 to 3 of sine cube root of x, it's less than the max. But what's the max? The max is when you plug in when you plug in 3 into the cube root of x there. So I'm not going to write max. I'm going to put the actual value in. It's less than b minus a, which is 3 minus 2 times the max. I'll write that in. So max of sine of cube root of x, right? Because that's the biggest rectangle. The picture is this. We're going from 2 to 3. There's blah, blah, blah. It's increasing. So the area under the curve is less than what the value is at 3, and it's greater than the value at 2, which, by the way, is greater than 0. Okay, so let's put that in. So that's equal to 1 times, because it's 3 minus 2, times sine of cube root of 3. Okay, and then on the other side, it's greater than or equal to b minus a, which is 3 minus 2, times the min of the sine. Cube root of x. Okay, and so what's that? Well, since it's increasing, the min happens at 2. So we've got, that's going to be 1 times sine of the cube root of 2. Okay, and then you go put those in your calculator, and you'll see that this is greater than 0, and this one here is less than 1. So from 2, the integral, sorry. Okay, so here's what we got. From the sine of the cube root of x, okay, that's definitely less than 1. I didn't put this in my calculator. Let me do it right now. Let me get it. I wasn't going to do that, but I think it's a good idea, so I'm doing it now. I'm going to find it. Okay, so I'm doing, I'm going to do, first I'm going to do sine of cube root of 3. Okay, so I go 3 cube root, and then I'm going to do sine of that. Okay, and that's this part right here is 0.02517. Okay, and that's less than 1. Okay, and then over here, this one here, we'll do sine of cube root of 2. 2, and then cube root, and then sine. That one is 0.0219, so that's greater than 0. Okay, so that's what we learned, that this is less than 1 and greater than 0. But then that also means, because the problem was asking about from negative 2 to 3, so the integral from negative 2 to 3 of sine cube root of x dx is less than or equal to 1 and greater than or equal to 0. And you can add in here since the integral from negative 2 to 2 of sine cube root of x equals 0. Okay. Not not that smooth here. I could do a little better. Certainly could do a little neater, but I'll hopefully talk you through that. Okay. So I think the video is long enough now, so I think I'll stop, even though I only did 3 problems, but those are kind of doozies. And that's actually going to be the case from here on out, because the rest of the problems from this section are, they're applications and they're theory questions, and so it's going to require a little bit more explanation than just doing these u substitution integrals. Okay, I'll see you in the next video.